question after we've sketched a graph. Okay. And this can be the domain and range of the graph. Okay, how you can remember. I'm going to write it at the bottom here. Okay, domain. If you can remember domain, you'll remember range. Right, so can you see the D in domain? You can make it an X. Can you see? Can you see the X? Hello? Okay, so the domain is all your X values. Your range. Okay, so now obviously if domain is your X values, range is going to be your Y values. Okay, but now you say to me, man, what do you mean by that? I'll show you now. Okay. Okay, so vitally important things to remember when it comes to a linear parabola. Okay, first things first, we've got the general rule, which is y equals ax squared plus q. That A tells me if it's a smiley or a sad face. That C is the y-intercept / turning point. Okay? We've got two x-intercepts for quadratic. Okay? We've got an axis of symmetry, which is the x equals 0 line. Then we've also got a maximum or a minimum, depending on which way your graph is going. A sad or a happy. Okay. So, for example, if I were to ask you this graph here, do we have a maximum or a minimum? A maximum. Because even though it's a sad face, it reaches the top. Okay, so it's a max. It's the highest point. And if it's a sad face, it's going to be a minimum. It dips. Okay, and your maximum will be at this point. Does that make sense? Yes. Right. Yes, yes. So that point over there, this -5 is your y-intercept. It is your turning point, but it's also your max. Yeah, that's fine. Okay, now I'm going to use this example to explain domain and range to you. Okay, when we're looking at the domain of a graph, we're looking at the x-axis. That's what we're looking at. Okay, so take your ruler and you're going to place it vertically on your x-axis. Okay, now you're going to tell me, okay, we're going to look. Can you see that this graph continues this way? Up to infinity, we don't know where it ends. Okay? So do you agree that there's no restrictions on the x-axis? Because all of these values are included in the graph. So yes, we've got an x-intercept, but if we move on, there's going to be another x value on the graph. And if we go, it's going to just continue and continue. So there will always be an x value. Do you understand? Going to the left and going to the right. So, do you agree with me that I can then say that for a quadratic equation, there is no restrictions on the x-axis? That means that our domain is going to be x is an element of real numbers. X can include any number on this graph. Why? Because any point here, do you see? Any point on the x-axis, it will lie on the graph. Do you see? And going that way as well. And this thing's carrying on up to infinity in both directions. Can you see? So there'll always be a point on the graph, on the x-axis, depending whether you go to the left or to the right. That means that for a quadratic, your domain is going to be x is an element of real numbers always. So if I ask you for the domain of a quadratic, you are going to write down x is an element of real numbers. Always. Unless they give you a restriction, but in grade 10, yeah, it's going to be x is an element of real numbers, yeah. So hold on. Then if we had to look at the range is now your y values. Okay, so now we're going to take our ruler and we're going to place it on my y-axis this way. So looking at this graph, okay, so can you see going here? Okay, carries on up to infinity going down, right? So on my y-axis, it's going to touch the graph. Do you see? Even going more negative, because this thing continues. It's going to carry on touching, going towards the negative y-axis. Okay? However, when we get here, does my graph continue above y equals 5? Do you see? It doesn't. It turns there. Changes direction and comes down. So do you agree that my range can be any number of y that is going to be less than 5? But it also includes 5 because it turns at 5. Do you see? So if I had to ask you the range of a quadratic, it's always going to be, depending if it's a happy face or a smiley face, it will always be either less than or equal to the turning point. Depending on if it's going up or if it's going down. So for this one, y must be, it's going towards the negative side, can you see? Y must be less than, but also equal to 5. Do you understand? Because from 5 going down, less than 5, there's going to be a y point on the graph going that way. All the way, and this thing carries on up to infinity going down. Okay, do you understand? Right. Example 3. So, we have sketch the following. That's what we'll be given in a text. That's all I'm going to give you, is this. That equation. Sketch. Okay, then what you're going to do is you're going to go and have a look at it. First, suss it out a little bit. Okay? So, first things first, we know it's quadratic because my highest exponent for x is 2. Okay. Let's check it what A tells me. So, A is positive, so we know it's going to be a smiley face. So, my shape is going to be facing up. Okay? Okay. What else can we tell from the equation is that? Plus 2. So, we know that that plus 2 is your y-intercept slash turning point. Okay? So, quickly, even just looking at the shape, are we going to have a maximum or a minimum? It's going to be a minimum because it dips. Do you understand? So, we'll have a minimum because it dips. Okay? Okay, then we have the y-intercept, which is 2, we just said. We know in order to sketch, we need both x and y-intercepts. We've got the y-intercept, so all we need to do now is to go and find the x-intercept. To go find the x-intercept, we make y is equals to 0. Okay, let's check. Okay, let's do a calculation here on the side quickly. Right, so we're going to go say 0 is equals to 2x squared plus 2. Okay, you with me? We're going to solve now for x. Normally, take the 2 over, it becomes a negative 2. So we have negative 2 is equals to 2x squared. To get x on its own, divide both sides by 2. So x squared will be equals to negative 1. Please look here. What's the problem? There's a negative underneath the square root, which means this is non-real. Okay, so now, remember with the linear, when we didn't have that plus c, we had to go make x is equals to 1. That's what we're going to have to do here. Because there is no x-intercept. The x-intercept, we won't have any. And I've just showed you now we're not going to have any, right? I just showed you why. Because if we had to go solve, it's going to give us non-real. Okay. That means exactly the same as a linear. We still need another point. So all you're going to do is you're going to go substitute x is equals to 1. So we have another point to plot. Okay, so we go choose x is equals to 1. Wherever there's an x, I substitute in that 1. Put that into your calculator. 1's friend that I've just substituted in is 4. So that's my second coordinate. Do you understand? Do you all understand? Right, now we sketch this. Okay, we know that my y-intercept is 2, which we got from our equation. And our second point is 1 and 4. So you'll just go and you'll go follow on your Cartesian plane, and you'll go and draw your dots. And now you see you kind of just need to, we don't have another point on this side. Doesn't matter. Okay, you must just get the shape fairly similar to one another. As long as you have 2. It must have its shape, even though we don't have another point there. You just go and... Okay, so when we calculated the x-intercepts here, this showed me that we don't have any. It doesn't cut the x-axis. So when we sketch it, does it confirm that? Do you see? Does this graph cut this x-axis? No. None of the arms cut. It lies above the x-axis. The whole graph lies above. There is no x-intercept.
That's how.
Right. Okay, so do you see here? Here's what I just showed you. If you had to go and calculate the x-intercept, do you see how you'd have no solution? Okay. Right. Then if I had to ask you, what is the equation of my axis of symmetry? What is it? X is equals to? Okay, there it is there. Equation of the axis of symmetry. X is equals to 0. If I had to ask you, okay, eyes up at me, do I have a minimum or do I have a maximum? Okay, I've got a minimum. And what is my minimum? Okay, where y is equals to 2. Don't just write 2 because are you telling me it's the x or the y value? Do you understand? Okay, so my minimum value is x is equals to 2. Okay, we fine. Sorry. Okay, my minimum x is equals to 2. Then, if I had to ask you, what is my domain? Always. X is an element of real numbers. Okay, can you see? Domain, x is an element of real numbers. Are we good? So, do you see how they write it? Just so you don't get confused. The domain, and what graph is this? H. Do you see? That's not a P, sorry. It's a D. Domain of H is x is an element of real numbers. Okay, then I ask you, what is the range? So what you're going to do is how I taught you. So the range of H, you're going to go write down a Y and you're going to go write down your turning point, which is 2. Okay, now we need to go and check which way our crocodile mouth is going to face. Okay? So do you see my graph is going more towards the positive side. So y must be greater than or equals to 2. So the crocodile mouth must eat y. Y must be greater than or equals to 2. Okay, grade 10s. Let's quickly have a look. I showed you we understand the concept of increasing and decreasing with a linear function. Okay, so I'm going to quickly move on. A linear function can either only be increasing or it can only be decreasing. It can never be both. Okay, so if we're looking at a positive quadratic function, okay, I want to show you guys that going from left to right up until our turning point. So our turning point is approximately over here and here. Okay, so from my turning point, to my turning point, can you see this piece over here? Which way are we going? Are we increasing or decreasing? Okay, we're moving that way, which means we are first decreasing. Can you see? And then at the turning point, it changes. So from here to here, what happens? It increases. Can you see? Different to a linear. A linear can either only be increasing or decreasing. Okay, and then if we have a sad face quadratic, okay, what's happening from here to here? Okay, this one first increases and then decreases. Right, so in a test, all that's going to be given to you is that. Find the equation of that graph. Okay, so just like we did for linear, your first step is to go write down the general form of whatever graph you're working with. And that is quadratic, which is y equals ax squared plus c. You write that down. After you've written it down, you have a look at what they give you. What can you substitute straight in without even doing any calculations? Okay, they give us c, which is, okay, our turning point slash y-intercept slash max or min. Okay, can we see it's 4? So we go ahead and straight off the bat, we're going to substitute 4 with c. Okay, and just like a linear now as well, it stays the same. Everything stays the same. We need to go and calculate our value for a. But now we've got a slight problem because, remember, the only way we can solve for one variable at a time is if we only have one unknown. But the problem is we've got x and y in my equation as well. But what can we go and substitute into x and y? At least one coordinate that they've given us on the graph. And have they? Okay, the coordinate is 5 and -1. So we're going to go and substitute this into x and y. Okay, so this is x's value, so that will go in here. And this is y's value, so that goes in there. Okay, are we happy to say that we've eliminated all other variables and we only need to calculate a? Okay, right. So now, normal linear equation. Okay? We can see that 5 squared is going to give me 25, okay? Okay, so I'm going to have 25a plus 4. I'm going to take that 4 over, and it's going to become a -4. Okay, so this goes over, it becomes -4. -1 minus 4 is -5. Divide both sides by 25. So a is equals to -1 over 5. Any questions? Okay, finish it off for me. My equation is a's value, which is what we calculated. Okay, a's value is -1 over 5, and c, which we got from the graph. Okay, what is, do I have a max or min? Okay, my max is 4. Okay, what is my domain of G? Always, same thing. X is an element of real numbers. Can you see that never changes? Okay, and what is my range of G? Okay, when I told you when you're doing your range, you write down Y, you write down your turning point. Then it's going more towards the negative side. So Y must be less than or equals to 4. Okay, another thing, what is my equation of the axis of symmetry? Thank you, I heard it. My axis of symmetry is x is equals to 0. Okay.